Hello everyone, my name is Vaibhav Chaturvedi. I am a final year student of Institute of Engineering and Management, Sector 5, Salt Lake, West Bengal.
Hello everyone, my name is Arunakshu Pramanik. I am also a final year student of Institute of Engineering and Management, Sector 5, Salt Lake, West Bengal. So we have developed a model on annotation system in healthcare domain as our final year project. In the upcoming slides, we will be discussing about the development and implementation of the model. So before going into the deeper concepts about the project, firstly, we would like to explain what is an annotation system. Basically, an annotation is a summarized explanation or a comment of an object which is attached to its footnote. The object could be anything. It could be a picture or a video or a text itself. Here we see in the given example how an input sentence has been annotated as organization or product. The words Google, Apple, and Amazon are tagged under the category of organization, whereas Siri, iPhones, Alexa, Echo, and Dot are tagged as products. To start with, we have a use case scenario of our model which will help you analyze the objective of this project. Considering the above scenario as a part of our day-to-day lives, we present a model which is capable of annotating medical terms provided as input, which further classifies the input terms as diseases, symptoms, human anatomy that is a part of a human body, drugs, and other medical terms. Now, this being done over the conversation between Joe and the doctor, it would have made easier for the doctor to understand Joe's problems, and it would have become easier for Joe to understand what the doctor had to say in response. Such a model will make the interpretability of such conversations way simpler. To develop such a model, we took the following measures. Firstly, web scraping, that is gathering necessary online data as conversations. Next, we pre-processed that data to make it worth trainable. This was followed by choosing a required model and training it for classification. Finally, we take an input from the user and predict based on our trained model, wherein the required terms are tagged accordingly. We have designed two models to achieve the desired objective. The first model is a machine learning model, which is a word-oriented model, while the second model is a deep learning model, which is sentence oriented. Both these models work independently and provide different accuracies, and it is found that the sentence oriented model performs better than the word oriented model. Now, my project partner Vaibhav will guide you through the development of these two models and their results.
Hello everyone, this is Vaibhav. From here onwards, I'll guide you through the development and implementation of the model. For the machine learning model, we have collected our dataset using web scraping from medhealth.com and processed the text accordingly to design a machine trainable model. Then the dataset is trained accordingly by the two popularly known models that are logistic regression and naive classifier. The outputs from which are further classified as symptoms, diseases, human anatomy, and drugs. The results of this model were not satisfactory, although the model was accurate enough to mark medical terms. This can be understood by the accuracy values available to the left. The model fails when big sentences of around 40 words are given as input. The best accuracy was achieved only when a part of the training dataset had been given as an input. This made us resolve that a better dataset is required for training and we need to design a deep learning model to improve performance. Now, for the deep learning model, we have collected dataset from various sources like medicinenet.com, drugbank.com, and medhealth.com. This information was also processed to make it worth trainable, but the difference being that this is three-dimensional in nature, as it contains properties about both sentences and words. This vector was passed to the LSTM layers, which included 128 LSTM cells, and was followed by a three-layered dense neural network. Just like the previous model, this output was passed to symptoms, diseases, human anatomy, and drugs model respectively, which further categorized the medical terms. This model gave us way satisfactory results, as can be seen by the accuracy values available to our left, but had its own constraints, as in many cases stop words were tagged as medical terms and many times diseases were tagged as symptoms and vice versa. The drugs model did not perform good either. Thus, we resolved that we should separately treat stopwords as their corpus is readily available in the NLTK module. Post doing this, we saw a 2% hike in the accuracy of our ensemble model, which is indeed an achievement. This can be noticed towards the left of the results table. For future respect, we resolve to make improvements to our dataset and keep updating our models with the latest medical updates. We are also trying to incorporate spell corrector and grammar corrector to avoid possible false taggings and update our ensemble model accordingly. Now, we come to the usefulness of this project. There are several domains in healthcare where our model can contribute. We are going to talk about the most generalized use cases. As the model improves cost control, acts as a guide to the doctors, increases service capacity, reduces personnel costs and inventory levels, improves the quality of patient care, and also acts as recommend to solutions to both doctors and patient. Now we look at an example where the tagging has already been done. In this input, which is a paragraph, we can see that the medical terms diseases, human anatomy and symptoms have been marked accurately. With this, I am Vaibhav Chaturvedi signing off. Thank you.
And this is Arunakshi Pramanik signing off. Do share your feedback with us. Thank you.